So, yeah, hello all, and welcome to today's webinar. Oh, sorry. Yeah, yeah. So, welcome to today's webinar on kinematics to code. So, we are going to see robotics simulation automation studio. Okay, so we are going to see the new robotics library, which we have introduced in Automation Studio version 9.0. So, we will also see how we can design motion program using the motion program manager. We will see the design using Mitsubishi PLC. We will see the Workcell visualization. We will see the control panel and also the new catalog, robotics catalog, which we have introduced recently, that is RobotPhoenix and Mitsubishi robots. So before moving to the presentation of the software, I would like to talk about our company, what we do and what our products are. So we are a team of 150 engineers and software specialists. We are ISO certified company and we are leading the industry by designing world-class trade-oriented tools in the fields of fleet power, electrical engineering, industrial automation, and custom software development. We have three offices. Our headquarters is at Montreal, Canada. Then two subsidiary offices, that is in Mannheim, Germany, other is in Pune, India. So we have in-house expertise in various fields like software specialists in software engineering, database design and support, network support, multimedia applications. We have engineers providing engineering support, also working in various technologies like pneumatic systems, hydraulic systems, mathematical modeling, electrical systems, automation engineering, robotic systems. We also work in industrial automation like PLC programming, SCADA systems, human machine interface. Okay. Then electrical controls, process simulations, and robotics. So these are our products. We have Automation Studio Professional Edition to create, analyze, troubleshoot, and validate multi-technology circuits. Then we have Automation Studio Educational Edition to train future technicians and engineers on hydraulic, pneumatics, electrical, robotics, process control, and PLC systems to simulation. Then we have Automation Studio Live Manifold, which is a complete hydraulic manifold software solution for design, coding, and prototyping. And then we have Andon Studio, which is a complete solution to optimize your production, or you can say it is more related to production planning or industry 4.0. So these are our objectives. We believe in long-term relationship. We have a effective support by phone, email, or online. We have a dedicated representative for each account, and we also provide support materials like training videos, demonstration file, quick start guides, etc. So these are some of our milestones. As we started in 1986, we were then known as HydroSim and NeoSim. Later on, we started with Automation Studio 1.0. Right from then till now, as per the customers' feedback and their requirement, we are growing ourselves, and currently we are working on Automation Studio 9.0 SR3. Okay, service release 3, and after this soon we are going to launch version 10 also. Okay. Again, like what is exactly the Automation Studio software? It is a multi-technology software which deals in various fields like simulation, animation, trade-oriented system design, and machine documentation. So you can draw your circuit using hydraulics, pneumatic, hydraulic manifold blocks, some part of mechanical, electrical control, electrotechnical one line. We have separate library for digital electronics, instrumentation, process control, robotics. You can also draw the circuit using PLC ladder logic like Allen Bradley, Siemens, IEC standard, Mitsubishi. You can draw the circuit using block diagram. You can also link your circuit to the trainer kits or the hardware kit using CAN bus or the OPC client server. You can also create the circuit using sequential function chart. Um, Okay, so you can create the circuit in ladder logic, SFC, graph set compilers, okay, and you can export to PLCs and XML formats also. We have some extraordinary features like workflow manager, API script language, FMA, teachware, manufacturer's catalog, bill of material and reports, component sizing, energy consumption. Okay, so you will find all these technologies or all these features in a single platform. Okay, and our software fits for multiple programs as you can see here. So what are the key benefits of Automation Studio with respect to student, teacher, and school? For student, it validated theory studied in class. Okay, it illustrated behavior dynamically in full color. So whatever a student is studying in his or her textbook, they can validate their circuits with the help of a software, that too in full colors. It also helps in facilitating demonstration of system interaction, also like enhanced teaching and learning by working on virtual system. No need to purchase single technology software as it is a multi-technology software. You can use this software in conjunction with other departments also. Okay. You can also provide e-learning or remote access to students. And for example, you can like if student wants to you work on like some projects or homeworks, they can use this software to complete their project or the homework. Okay, so that is possible. We have an international presence. We are available in 13 languages and we have sold our software in more than 150 countries. Our software is used in high school, career centers, colleges, universities, workforce development. We also provide some technical publications in Automation Studio. For example, you can see this circuit. This circuit is from this book, that is Fluid Power with Applications by Anthony Esposito. Similarly, there are many other circuits available from different publications. You have to just click on Technical Training Material tab and click on the exercise which you want to use or the technical publications which you want to work. Okay. Again, there are interactive exercises available in Automation Studio. In this way, you can create your own interactive exercise which are easily customizable, and you can see how you can work on this. You can also create digital twin of your own equipment. For example, you might be using such kind of trainer kits in your schools. Okay, so you can see what we have done. We have created the same circuit in Automation Studio, and we have linked the Automation Studio circuit with the trainer kit using the third party okay, OPC server, and we have created the digital twin of our own equipment. You can create the circuit using illustrated libraries also. So we have illustrated libraries for PLCs, hydraulics, AC/DC motor control, then pneumatics. Here you will find like three ways to create, simulate, and troubleshoot. You can create the circuit using symbols, ISO symbols, then illustrated components, and the virtual trainer kits also. Okay. So here you will find the difference between the actual pneumatic trainer kit and the virtual trainer kit, which is from Automation Studio. So on the left hand side, you can see the person is connecting the circuit, completing the circuit using the pipes, flexible pipes. On the right hand side, again, we have created the circuit and connecting the circuit using the curved links. You can see. Okay. Okay. Now, what are the benefits of virtual plus hands-on experience? Right. So if you're only going for trainer kits, so it is really an expensive option, and there are multiple limitations on this. Okay, as you can see here. But if you're using hardware with Automation Studio licenses, there are multiple benefits here, and it will be an affordable option also. Also, one of the most important feature of Automation Studio is the manufacturer's catalog. So what is exactly manufacturer's catalog? We have pre-configured ready to simulate manufacturer specific components available from all these manufacturers. You have to just go to the manufacturer's catalog, click on the component which you are using, right? In this way, you will be able to build the industrial compliant circuit. Okay, so can you mention any of the manufacturer's specific component which you are using? You can mention in the chat box or the question pane so that we will understand that which are all the components you are using, right? So you can mention it in the chat box or the question pane. Okay. So this is the partial list of our industrial clients. We have clients like NASA, Boeing, John Deere, Kubota, Caterpillar, Hitachi, JCB Defense, L&T, China Steel, US Steel, Komatsu, Epiroc, Honda, RV High-Tech, Skyjack, Terex. Yeah, this was about our company profile. So if you have any questions till now, you can type it in the question box. Okay. So let me move to the software part. Okay. Okay. So yeah. So this is the interface of Automation Studio Educational Edition 9.0 SR2. Okay. And soon you will be getting the new versions also. So today's webinar is focusing on robotics part. Okay. So here you will find all the libraries. Let me give you an overview of the interface first. So on the left hand side, you will find the library explorer where you will find the technology like hydraulics, proportional hydraulic, pneumatic, proportional pneumatic, drive and transmission elements, environment and control, instrumentation, process control diagram, electrical control, GIC and IC standard, digital electronics. Then we have different types of ladder diagrams like Allen Bradley, IC standard, Siemens, LS Electric, Mitsubishi, electrotechnical IC and NEMA standard, electrotechnical one line blocks, HMI control panel, and then robotics. Okay, so today we are going to focus on robotics. So here, like for the those all these libraries which you are seeing, we have already conducted webinars in last week, which you have attended. Okay, so if you have not attended in future, we will again conduct more webinars on this, and we will send you the invitations. Okay, or you can let me know through chat that you have not attended and you want to attend the webinar on these particular topics. Okay, so we will try to arrange one webinar for you again on that. The center part is your workspace where you can create your diagram. On the right hand side is the project explorer where you can find your current project. The ribbon bar where you will find the tabs like home tab, edit, view, simulation, system analysis, fluid tools, student tab, then support, and then technical training material tab. Okay. Now here, like we are focusing on robotics diagram. So in order to draw the robotics diagram in Automation Studio, you have to open the robotic document first. So I will go to new document here and click on robotic diagram. Okay, in this way, the robotic diagram sheet will open. Okay, so here, like we have different types of robot. Like we have introduced like 6-axis articulated robot, 4-axis Kara robot, then cobot also 6-axis collaborative robot, right? So currently we have this, and with the updated version you will find other robots also. Okay, then you can see the tools tab where you will find different types of tools like cylindrical tool, conical tool, suction tool. We have loads like prismatic load, cylindrical load, spherical load, conveyors also you can see. Okay, so here it is very easy to use the robot. You have to just drag and drop the robot here. Okay, you can take this kind of robot, cobot also we can take. Okay, so you can drag and drop this kind of robot. Here in the robots again, you can just double click on these robots and you will find the details or the yeah, details of the robot or the properties of the robot. For example, you can add the description here. You can see the envelope transparency, percentage of envelope displayed. Okay, you can see the robot simulation mode like kinematic dynamics. Okay, you can see other like linear speed. Okay, the digital input output number of accesses. Okay, references you can see, tool frames you can see. Okay, yeah. Then we have like cobot also you can see. Here you can display the envelope 2D and 3D envelope. When you display the 2D and 3D envelope, okay, so you can see you will find the scope of the robot. Okay, so in you can see the scope in which the robot can travel. Out of this, there is no scope for that robot. Okay, right. Now we have different types of tools also. Like we have cylindrical tool. Okay, in this way you can attach it. You can use this conical tool also. In this way you can also use a suction tool. Okay. Now again for these tools also, if you just double click, you can change the tool function to gripper, finger. You can change the dimensions of the tool also. That is also possible. Even you can change the color. If you want to change the color, you can change the color. Like you can see I'm changing the color here. In this way, you can change the color. Okay. Now again we have different types of loads here. For example, we have prismatic load. Okay, so let me take this here. I will delete this for now. Okay, I will focus on one robot only first to show you. So I'm taking these loads here. Okay, so I'm taking these loads. So here for these loads also you can change the color. For example, I'm making this color here. Okay, so like this you can change the color for this loads. You can also change the data properties of this load, like you can see the dimensions. You can also give the mass also. Okay, if there is some mass from that particular object, you can edit the mass also. Okay. Now again we have different components like conveyors we have, curved conveyors, sensor we have. So I will show you that also. Okay. Now if you see the home tab, so with this robotic diagram, the home tab will also change. You can see. Okay. So in this way, the will change the view section will be changed. Now here you can see a tab is added that is of robotics. So here the two sections are important, that is motion program manager and the control panel. So with the help of motion program manager you can create the motion program, and now with the help of control panel you can see you can control the robot, right? So for example, here you can add with the help of dragger mode you can move the robot or control the robot as per your requirement. Okay, so you can see. Okay, so you can see even we have this spherical mode also. So you can control this. Okay. Now again, like we have different mouse selection mode with the help of which you can locate your robot anywhere in this workspace like this. Okay. So like this, you can just locate your robot. You can also control the speed of the robot. Then you can also give uh, you can like control the robot using the different mode like Cartesian mode or the joint angles. You can use different joint angles to control the robot, right? Again, we have different home position with the where you can control the robot. Like we have this by default position, okay, where the joint angles will be 0, and again there is a to do position or the work position, okay, can control the robot, right? Again, the most important part is the motion program manager, with the help of which you can create the program for a robot, right? So as this is a six axis articulated robot, by default it will be selected as 6-axis robot. But if you have other robots on your workspace, it will show you which robot you want to select. Okay, so for each and every robot, the motion program will be different. Okay, so I'm creating motion program for this robot. Okay, so here I will create a motion program for this robot. I will add the motion program from here. You can see some tabs will be visible here. Okay, in this part. So here is the identification tab with here, like you can change the color of the path. Okay, so some kind of like cosmetics part, properties like the color type, line type. Okay, so you can select this. Then here the program tab is there, where with the help of instructions you can create a program for this robot, right? Again, there is a tab like a waypoint, so you can select the the locations with the help of which the program will be designed. So here we have to create the waypoints first. So I will click on add waypoint. Okay, you can click on add waypoint. So I will give some like for the program, I will give some instructions to this. So I will add the waypoint like home. You can see a waypoint is created. Again, with the help with the mouse selection mode, I will locate the robot here, and I will say box cylinder. Sphere. Okay, so here you can just like create this. Okay, now you can see the reachability. The reachability is also shown here. Okay, so you can see the waypoints are created. So with the help of this waypoints, I will design a program. So I will go to program tab, and here you will find different instructions, like we have J instruction, L instruction, C instruction, wait instruction, DO instruction. Okay, so with the help of this waypoints, I will design the program, right? So I will take the instruction here. Okay, and so like I will select the waypoint first, this one. Again, I will create one instruction. I will say cylinder, right? So I'm just creating a simple program. Then I will create one complex program also in order to show you. Okay, so this is one simple program which I have created. So just to show you that the robot will travel from this box to this cylinder, and it will travel to the sphere, and it will move to the home position again, right? So what I will execute this program. You can see, and click on this, so you can see the program has started. Okay, so you can also display the path, and I will make it in loop. You can also update the path here, so you can see the path will be displayed here in this way, and then we will start the execution. Okay, so in this way you can just create the robotics application in Automation Studio. Okay, Okay, so this was about like how to create the motion program. This was like simple application, but how to create a like some industry related application here in Automation Studio. So I will delete this motion program and I will delete all this. Okay, I will take a conveyor here. So we will take this. Okay, so you can take this. Similarly, I will take again this one. Okay, so I will take this in this way. So you can see this. Okay, and now again I will use this curved conveyor, right? So let me make this invert direction. So here again for this conveyors also, if you just double click on this conveyor, you will find the description box. You can also add the input output tables here. You can change the height of the conveyor. You can change the like length, maximum speed. Okay, so I will change the direction to invert direction. Okay, so here again I will change the inner radius to some 120. So I will make this in this way. Yeah, so let me take one more here and I will make it to like again 120. Okay, so here I will make it to, so you have to just adjust this. So I'm doing randomly without, okay. So you can make the changes here. Okay, so I will move this a little here. So in this way, we have to just adjust this. Okay, you have to just adjust this. You can see it is now aligned, right? Now, let me also connect the sensor here. So in this way, I will connect the sensor here. Okay, and now we will take the loads also. So I will take one load here. Okay, I will change the color of this so that it will be understood. I will take one more load here just to place it. Okay, and then I will go to robotics tab. I will design a motion program here. Okay, design a motion program. I will select, I will create the waypoints. Okay, so first I will create it for home position as I have created for the earlier application. Okay, and then I will locate the robot here so that it will pick from here. So I will say box pick. Then I will say box place. Okay, and then home position. You can see the waypoints are created. So you can create the waypoints in this way, right? And then I will place this behind this sensor. Okay, and place this behind this sensor. Similarly, I will take one more like cylinder. I will take and I will keep it in the same place. And one more cylinder I will keep it here again in the same place. Okay, so here the color we will change it again to some green color. Okay, and then we will create the waypoints again. So we will place it on the cylinder and we will say, okay, so we will say some like cylinder pick. Okay, and then I will click it here and say it like cylinder place. Okay, so you can connect in this way. Okay, so again here I will delete this and I will place this behind somewhere here. Okay, so somewhere here I have kept it. Now, now what I will do, so I will not run the simulation for now. I will connect this simulation part to um, like the PLC, as this is a Mitsubishi designed robot. Okay, as this is a Mitsubishi designed robot, so I will like place this like or connect this robot to the PLC, Mitsubishi PLC. So let me take a ladder diagram here. So in order to create the like Mitsubishi PLC, we have to get the ladder diagram sheet. So I will take the Mitsubishi ladder diagram sheet here. Okay. And what I will do, I will change the view of this. So you can go to view tab and I will click on vertical view. So yeah, so I will take this kind of view here. So yeah, you can see. Okay, so in this way you can take the view, and here I will take the Mitsubishi ladder diagram. So I will go to Mitsubishi here, HMI controls. Okay, so I will take a momentary push button here to control the circuit, and I will name it at start. Okay, now I will connect this to some context. So I will connect this context here in this way. Here, so here we can see. Okay, so we'll connect this. Now we will like connect this PLC or ladder diagram to this robotic diagram. Okay, so how we can connect it? Okay, so before that we have to design a motion program for this robot. Okay, so I will go to Robotics tab here and we have to design a motion program here, right? So we have created the waypoints and now we have to design the program using the waypoints here, right? So it is very simple application that I will be picking this box from here after detecting by the sensor, and then I will be placing it to this other conveyor, right? So I will take linear instruction, okay, and I will say box pick. Okay, so you can observe how I'm creating the program, and then in order to pick the box we have to use this instruction, that is do instruction. So I will take this do instruction. Okay, and then I will say again L instruction. I will say it should go to home position. Okay, and then it should travel to box place and it will take D off. Okay, so I have placed this okay object on this other conveyor. Okay, and again it should move to home position so that it should again pick this cylinder, right? So this is the like program for your box, but now I have to create the program for the cylinder. So same again I will take the say cylinder pick and then I will say do. I will say home. Okay, and I will place this. Okay, and then D off. Okay, and then I will say home. Okay, so you can see I have created a motion program here, a simple motion program. Okay, so you can see this is the motion program for your robot. And now we have to link this motion program to this Mitsubishi ladder diagram. So how you can link it? Okay, so here I am going to this ladder diagram. I have to go to ladder diagram tab here. Again, you can see a ladder diagram tab is visible, and I will go to PLC configurator. Okay, so I will go to PLC configurator. So in this way, the PLC configurator will look. And here we have to create the variables for this ladder diagram. Okay, so I will go to variables here, and I will create a variable like for the start. I will create like the start. Okay, so this is for this variable. Then for the conveyors, we will add like conveyor. Okay, so I have created one conveyor. Then for sensor, okay, because when the conveyor will start, the sensor should also start. And then for the robot, okay, so robot we will create it for robot. Okay, so you can see this type of variables we have created for the robotic diagram. Okay, for the and ladder diagram. And then we have to link this variable to the signals of this robotic diagram. So I will go to input output tab, and then I will add this link the variables. So I will search for the variables of the robotic diagram. So I know the variables like these are like conveyor forward. Okay, then we have like this sensor one and the start. Okay, so I have taken this variable. So one variable is not visible here, that is of robot. So here you have to go to the robot, and so I will give the input here, and this I will create the start motion program. Okay, so now when you go to this ladder diagram, so here you can input port. So you can see all the variables are visible here. And now what we have to do, we have to link these variables to the here these variables. Okay, the variables given here. So for the conveyor forward, I will copy this here. Okay, and then I will also connect this to the robot to this robot sensor. I will connect this to sensor here, and start I will connect it here. Okay, so you can see the variables are linked here. And for the robot, I will make these two output. Okay, so in this way you can connect the variables to the PLC, right? Okay, and so now what we will do, we will connect these variables now of this ladder diagram to this here, the selected Mitsubishi ladder. So I will double click on this. I will go to builder here. So first we have to start this like momentary push button in order to start the diagram. Then I will start the conveyor. As soon as the button is pushed, the conveyor should start. Okay. As soon as the conveyor will start, then the sensor should start. And as soon as the sensor will start, the robot will also start. Okay. Yeah, so you can see the ladder diagram is not now configured. Okay. Now, okay, so let me go to this robotic application. Okay, and I will make it active. Okay, yeah. Okay, now I will start the simulation, and you will observe this thing. Okay, so you can see uh, motion program robot pace. Okay, so here the robotics. Okay, yeah, and now it is controlled using this. So, so you can see how you can pick this. Okay, so in this way you can create your own motion program. Okay, so so you can keep this little behind of this. So you can see in this way. Okay, so you can see, you can see in this way you can create the robotic diagram here, right? So you can make it in loop, right? So if you have any questions, you can type the question in your question pane. Okay. Okay, so this was about the robotic diagram. Now the important part is like how to export this program. So it is very easy to export the program. You can just double click on this robot, sorry, not robot. You can go to the robotics tab. You can go to motion program manager, and here you will find the option of export. So you can click on export the program, and in this way you can export the program to your own robot, Mitsubishi robot. Okay, so you can export in this way. Okay. So Mitsubishi robot like now again, yeah, so here this was about the robot with PLC. We have also introduced robotics in our catalog. So if you go to online catalogs here, so you will find so different types of catalogs, and here you will find different robotic catalogs. Like we have Mitsubishi, you can say we have Mitsubishi industrial robots. So here where you will find like all the types of robot, like we have vertical type robot, like horizontal type robot, you can see. Okay, we have like ceiling mounted robot, we have like cobots also. Okay, so this type of collaborative robots also you can use it. Okay, so you will get the robots with the particular part number and the specification sheet. Okay, also you will get a test bench where you will find the robot as tested. You will get a specification sheet of the robot again, which you can use it. Okay, yeah, same with the RobotPhoenix catalog. You can see the RobotPhoenix catalog. So we have this type of like Scara robots. Again, we have this like 6-axis articulated robot also. You can see with the specifications. You can also find the image of the robot. Okay. So now let me show you like how complex you can go in this robotics diagram. So Okay, so I will save this. Okay. Okay, so I will save this and then open the other file. Okay, so here you can see in this example, you will see that again the robot is connected to the PLC. Sorry. So you can open the like this screen, and when we start the simulation, you can see here the again this 6-axis articulated robots are linked to this conveyor and the sensor, and you can see how they're picking and placing the object. Okay. Okay. So in this way, you can design your robotic diagram. Similarly, other example which I want to show you is of this one. The robot is changing the orientation of the object. You can see. Okay, in this way you can just connect it. Okay, so you can create the program in this way. Okay, and this is one example of 4-axis Kara robot. So here, if you start the simulation, you can see how this robot is following the path. Okay, so in this way, you can create like use the robotics library to create the robotic diagram. Now, okay, so last example I will show you of this. Yeah, in just a second, I am showing you two videos I will show you. Yeah, so this is one like application circuit for RobotPhoenix. So this I will play the video as we are short of time. So you can see this is an example of RobotPhoenix where the 4-axis Kara robot is just detecting the object and placing the object. Okay, so in this way you can design your robotic diagram. Okay, same with this Mitsubishi. You can see. Okay, so in this way you can just create the diagram using the various robots. Okay, yeah. So so that is all from my side. If you have any questions, you can ask the questions, right? You can type the questions in the question pane. Yeah, so anybody has any question, you can type it in the question pane. So this is my mail ID. So if you have any questions related to the software, or if you want to give the feedback, if you want the quotation or the personalized demo, so you can just write me. Okay. Yeah. Yeah, anybody has any question? So this was the last webinar of this webinar series and the last webinar of this month, right? So in the coming month, we will try to arrange more webinars. Okay. Yeah, so if anybody has, if nobody has any questions, um, so we will end the webinar here only. So thank you very much for attending the webinar. Okay, so we are looking forward for your participation in the upcoming webinars again, right? So thank you very much. Have a good day.